Hi, in this video, we'll be talking about combination of resistors. What are resistors? Well, resistors are electrical components that inhibit the flow of current. They are used to control the amount of current that flows in the circuit. And different combinations of resistors, be it in series or in parallel, will give us a different equivalent resistance or the total resistance. When you connect resistors in series, so as a review, what is a series connection? When you say series connection, then your electrical components are continuously attached to each other, giving or having one path for the current. So when resistors are connected in series, the current that flows through each resistor is equal to each other. Whereas the voltage in each of the resistor, the sum of all of the voltage dropped in each resistor will be equal to the total voltage of the circuit. And for the equivalent resistance or the total resistance of the circuit, excluding of course the resistance of the battery or the cell and the resistance of the wire, just factoring in the resistors themselves, so the equivalent resistance of the resistors will be equal to the sum of all of the resistors of the individual, or the sum of all of the resistances of the individual resistors. And for parallel connection, the current, the total current that flows in the circuit will be equal to the sum of the individual currents that flow through your individual resistors. Whereas the voltage experienced by each of the resistors, or the voltage drop in each resistor, will be equal to each other, which will be equal to the total voltage of the circuit. And the equivalent resistance, or R total, of your resistors in parallel connection will be equal to R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so on. So those are the quantities, or how we can solve for the quantities when resistors are arranged in parallel. So just a summary, you have here the resistors in series and resistors in parallel. When resistors are connected in series, the current experienced by, or the current that flows through each of the resistors will be the same. However, if it's connected in parallel, the total resistance will be equal to the sum of all of the total current will be equal to the sum of all of the individual current that flows through each of your resistors. For the voltage, the total voltage in a series connection of resistors will be equal to the sum of all of the voltages. And the voltage in parallel connection of resistors will be equal to each other. And for the equivalent resistance, when it's connected in series, then it's just the algebraic sum of all of the resistances. And for parallel resistors, then you have 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so on. So now let's look into several sample problems. Example number 1. 3 resistors with values of 60 ohms. So you have here resistors of 60 ohms, 30 ohms, and 20 ohms. So this is 60, this is 30, and this is 20, respectively. And they are connected in series with a battery of 110 volts with negligible resistance, meaning we do not factor in the internal resistance of the battery. So draw a circuit diagram. Here's our circuit diagram. And we will solve for A, equivalent resistance, B, current flowing through each resistor, C, the voltage drop across each resistor, and D, the power dissipated by each resistor. So let's solve for those unknown quantities. Well, our given values, of course, you have your resistance, you have your resistances in the resistor. So you have R1, which is 60 ohms. Then you have R2, which is 30 ohms, and R3, which is 20 ohms. And of course, you have your V total of the circuit, which is 110 volts, or your V. You have your V, which is 110. So for A, we need to solve for the equivalent resistance, or R total. So what's your R total equal to? Since they are arranged in series, remember that R total is equal to the algebraic sum. So that's R1 plus R2 plus R3. So that will give you R total will be 60 ohms plus 30 ohms plus 20 ohms. So R total is 110. There. Easy, right? For question B, what are the currents? So that's I1, I2, and I3. So what are they equal to? Remember, when connectors or when resistors are connected in series, your current flowing through each of your resistors will be equal to each other. Therefore, I, or the total current, is equal to I1, which is equal to I2, which is equal to I3. And I, or the total current, will be equal to, using the Ohm's law, we know that current will be equal to the voltage divided by the total resistance. So what's our voltage? It's 110 volts. 110 volts over the R total, which is 110, and that will give us a value of 1 ampere. Therefore, or if the current flowing through the entire circuit is 1 ampere, and if the current flowing through each of the resistors is equal to each other and equal to the total current, therefore I1 is equal to 1 ampere, I2 is equal to 1 ampere, and I3 is equal to 1 here. So this will be our answer. I1. For C, we are asked of the voltage drop. So how do we solve for the voltage drop of each resistor? Using the Ohm's law, we know that voltage is equal to current times resistance. So the use of Ohm's law will still be important in solving for these questions. Now, to solve for the voltage drop in resistor 1, so that will be, of course, the current flowing through resistor 1 and the resistance of resistor 1, which is, we have here 1 ampere times the resistance of resistor 1, which is 60 ohms. So that will give us a voltage drop of 60 volts. For V2, then that's I2R2, which will give us, it's still 1 ampere times, that's 30 ohms, so it's 30 volts as well. And V3, so it's I3R3, which is equal to 1 ampere times 20 ohms, that's 20 volts. And as you can see, if you check it, remember that the total voltage drops given by each resistor will be equal to the total voltage of the circuit. So if you look into the sum, so that's 60 volts plus 30 volts plus 20 volts is 110 volts, which is equal to the total voltage, or the voltage of the circuit. And lastly, for question D, we are to solve for the power dissipated by each resistor. There will be several formulas for power using voltage, current, and resistance, but for this case, we'll be using power is equal to voltage times current. So for power 1, or the power dissipated by resistor 1, so that's V1, I1. So what's V1 equal to? It's 60 volts multiplied by 1 ampere, that will be 60 watts. So this will be our answer, by the way, in question C. And for question D, so P1 is 60 watts. How about P2? So that's V2 I2. That will give us the voltage for resistor 2 is, or the voltage of resistor 2 is 30 volts times 1 ampere. So that's 30 watts. And power dissipated by the third resistor, so that's V3 I3. Then you have 20 volts times 1 ampere. Then that's 20. There. So we were able to answer the questions asked in this example. Example number 2. Now we have here resistors that are connected in parallel. So A, we solve for the equivalent resistance. So it will be the equivalent resistance of the circuit if, let's label this as R1, this is R2, and then this is R3. So for A, we are to solve for the equivalent resistance. And the equivalent resistance of resistors that are attached in parallel connection will be equal to, so that's R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So if you substitute our values for that, so that's R total is equal to 1 over 20 ohms plus 1 over 100 ohms plus, oops, that's 1 over 50 ohms. So your R total for this case will be equal to 12.5 ohms. So that's 12.5 ohms as the equivalent resistance for the combination of resistors in parallel connection. This is our equivalent resistance. Now for B, solve for the total current from the power supply. Remember that in parallel connection of resistors, each of your resistor will experience its own current, or the total current will be distributed to each of the resistors. So for B, what we are asked for is the total current from the power supply that flows through the entire circuit. So what will be the total current? So your total current, or I total, using the Ohm's law, will be equal to, so I is equal to V over R. So that's V over R total. And your V is 125 volts over R total, which is 12.5 ohms. Then that will give you total current of 10 amperes. So in the circuit, from the power supply, a total of 10 amperes will flow and will be distributed to the three resistors. For C, what will be the voltage drop across each resistor? So that's V1, then V2, and also V3. Now, to solve for the voltage drop in each resistor, remember that in parallel connections, your V will be equal to your V1, which is also equal to your V2 and equal to V3. Therefore, if V is equal to 125 volts, then therefore V1, which is equal to V2, which is also equal to V3, will be equal to 125 volts. Now for D, what will be the current flowing through each of the resistor? So that's current for 1. So I1, using the Ohm's law, that will be V1 over R1. The current that flows through resistor 1 will be V1 over R1, which is, well, V1 is 125 volts over 20 ohms, which will give you a value of 6.25 amperes. I2, which is V2 over R2, is 125 volts over 100 ohms. That's 1.25 amperes. And I3, which is V3 over R3. So to substitute your values, that's 125 volts over 50 ohms. And that will give you 2.5 amperes. Now, if you check it, the sum of the current that flows through each of the resistor will be equal to your total current, which is 10 amperes. So 6.25 plus 1.25 plus 2.5 is 10 amperes, which will help you determine if your calculations were correct. And for the last question in this example, what will be the power dissipated in each resistor? So the power in resistor 1 will be equal to, similar to what we did in the previous example, so that's V1I1. So the voltage for the resistor 1, or the voltage drop, is again similar to each other, so that's 125 volts multiplied by the current, which is 6.25 amperes, basing it to the previous, or to the calculations that we just had earlier in the previous slide. So that will be 781.25 watts. So this is the power that is dissipated by the resistors. So what does the power dissipated mean? Remember that when resistors inhibit current, they heat up, and power is dissipated through that. For the second resistor, so that's V2I2, so 125 volts times the current in the second resistor, so that's 125 amperes. Then you have 156.25 watts. And the power in resistor 3, which is equal to V3I3, you have 125 volts times 2.5 amperes. That will be 312.5 watts. All right. So these are the power dissipated in each of your resistors. Now, sample problem 3. So we will solve for the equivalent resistance of the combination of resistors as shown in this diagram. Now, how do we solve for the equivalent resistance in these types of circuits? Well, the best thing to do is to simplify your resistors. You combine resistors one by one until until the circuit becomes simpler, and until you arrive at the correct, or at the final equivalent resistance. So in this case, when we look at the circuit, we can certainly tell, or we can certainly solve the equivalent resistance of, or the total resistance of R2 and R3, because they are in series with each other, without any other paths, without any other components interfering with or between them. So to solve for the total resistance, we can solve it one by combining your resistors one by one. So we have here, to solve for R total, we can first solve for the resistance of R2 and R3. And since R2 and R3 are in series with each other, therefore, to solve for the total resistance of R2 and R3, it's just R2 plus R3, which will give you, or substituting your values, that's 3.5 ohms plus 2.5 ohms. Therefore, R2, 3, or the resistance of 2 and 3, is 6 ohms. So what happens now is that you already have simplified these resistors and you can treat them as one resistor already. If this is already one resistor, it's just both of them are 6 ohms, then you can combine, this is R23, then you can combine R23 and R4 because they are in parallel with each other, with no other components that will make the computation complicated. Now it's just R23 and R4 parallel with each other. So the equivalent resistance of R23 and 4, since they are parallel, so that's 1 over R23 plus 1 over R4. So it's R23 because we already combined 2 and 3. Substituting your values, that's 1 over 6 ohms plus 1 over 24 ohms. So your R234 will be equal to, you have 4.8 ohms. So that's for R234. But you still have R1 and R5. So we were already able to combine R2, R3, and R4. And R2, R3, and R4 are in series with R1 and in R5. So therefore, to solve for, so the those are the remaining resistors. To solve for the equivalent resistance, it's just R1, since they are in series, plus R234 plus R5. So in series, these resistors will be in series, R1, and then this R234 will be in series as well to R, or with R5. So substituting your values, that's 5 ohms plus R234 is 4.8 ohms and R5 is 9.2. Therefore, the equivalent resistance of this circuit is 19 ohms. There. So that's your equivalent resistance. So that's it for the combination of resistors. Again, when you solve for problems involving combinations of resistors, if the circuit is just series, so you follow the properties of the quantities in series, and when the circuit is parallel, then you just follow the properties in parallel. But however, if the circuit both has series and parallel resistors connection, or series and parallel connection in their resistors, then you need to simplify the circuit until you arrive at your final total resistance. So thank you very much for listening and see you in our next video.